So today we're going to start off with the remote access. So this is going to be a two-part lesson. So this lesson we're going to give you the theory, and we're going to look at dial-in VPN, which what does that mean? That actually means that someone working from home will be able to access your local area network by actually using their internet connection and dialing into your network and accessing the resources. So if we look at the worksheet for today, it'll maybe give us a better picture. So if we look at the worksheet today, one of the things you have to visualize is where things are happening. Okay. So if we look at this diagram, it's very important to visualize where these things are happening. I know in our unique situation, we don't have an ISP here and all that kind of stuff that becomes this internet cloud here. What we're doing in the classroom, or even if you're at home, is you're using your actual physical network as if it was the internet. Okay, and you're going to dial up from a computer that's on the internet to us into a VPN RAS server, and we're then gaining access to the resources that might be located in this local area network, which is on the host only network. Okay, so the key thing is that this computer has to have two interfaces at least. Okay, one pointing outside, one pointing inside. And obviously when we have a one pointing outside, that is the bridge interface in this case, and that's going to obtain an IP address from our DHCP server that might be on the TAFE-SA network, or if it's at home, your ADSL router or any or access point. Okay, and obviously you're probably going to ask, why don't we give ourselves a static IP address? So obviously if we give ourselves a static IP address, that can work as well, except that we have to make sure that everyone in the room on our network is not going to use the same IP address. Okay, in a class full of 20 people, getting that communication across to each one of you guys may be a difficult thing to get. Okay, so basically the easiest way for us in class is to do it by DHCP, because we know that DHCP server is going to allocate everyone a unique IP address, and it's going to have the right settings for the actual network we're connected to. Okay, so you'll find that if you move your virtual machines from home to TAFE, obviously this IP address is going to be different, isn't it? So therefore, when we dial up from a client, we're going to dial up either by name in real life. What does that mean by name? That means by DNS. Okay, so we all know that DNS resolves to IP address. So if this was a real life situation and I had an internet connection and this was my external interface and it had an IP address, I would use DNS rather than IP address. Okay, but obviously in the classroom at home, again, you probably don't have a DNS server on your home network. We have a DNS server here at TAFE-SA network, but I'm not in control of that, so I can't suddenly put all your entries in there. So therefore, what we're going to do is dial up the IP address directly, and that's entirely possible on the real life network anyway. So when we do dial up the IP address directly, if this IP address is different because you moved it from home to TAFE or vice versa, then you have to adjust the IP address here that you're using to wherever the IP address is at that point in time you're trying to dial up. Easy enough. It's just like if you're dialing someone's phone number on your phone and they've got a new SIM card, you don't keep on dialing the old number, do you? You dial their new number, wherever their number is. It's just the same idea. And obviously, if you haven't realized it yet, so if I was a computer on this LAN, so even if I was another Windows 10 computer or another server, in order for me to communicate with anything that's off this network, I have to use this as my gateway, don't I? Okay, so the internal interface is my gateway. In this case, it's .3 because that's what server 2 is always configured with. But in real life, it might be .1, might be .254, wherever you've designed your network IP addressing. In this case, it's .3 because server 2 has always been configured as .3, and this time we've actually made it into a VPN server or RAS server instead. So .3 will become the gateway for this computer. Okay, but in real life, in your assignment, it's not going to be .3. Okay, it's going to be wherever you set the internal IP address for your RAS server. Okay, and if you look back to your assignment, it's probably going to be .1. If we say .1, there is another problem as well that we have to be aware of. So if you know your VMware workstation, you know that when we look at the network settings, by default, when we have a computer, our host computer, when we have a network, let's say it's a 192.168.179.0, that's the host only network ID, isn't it? Okay. By default, when we have a host computer, it will automatically have a network interface connected to that network. You get me, guys? Remember that from 5VM? And when we do have a network connected to that adapter connected to that network, it's represented here. So you can see it's VMNet1. Okay, and obviously in our assignment, in our worksheets, we might be using 1 and 2. But you'll know that by default, because there's a DHCP server as part of VMware Workstation, that we're going to be given the .1 IP address. Okay, so for some of you guys, I think James is looking at me right now. If you've gone ahead and changed the configuration of the virtual networking to be exactly what your subnet is, that sounds like the right thing to do. But in this case, it's going to, because of that, it's going to allocate your host virtual adapter with the .1 IP address, which will be a conflict if you're using the .1 for the RAS as well. You guys are understanding what I'm saying? Okay, good. So what should you do? Well, there's a couple of things you can do. Firstly, maybe don't configure this. Bear with me. Don't configure this with the actual subnet you're actually using. You only need this if you're going to rely on the VMware DHCP server to give you IP addresses. Okay. Or secondly, do not connect the host virtual adapter to the network. Then that removes your VMNet1 IP address or a network card. Okay. So you get what I'm saying. So if I uncheck this and I click apply, you'll see that. Sorry, where's my other thing? I closed it. You'll see that my VMNet1 adapter just disappears, doesn't it? So therefore, it cannot conflict anymore. So there's a couple of solutions, okay? So just have to understand the fact that we're using VMware, and because of that, if it's the same network as what we're using, it's going to automatically allocate .1 to the host's VMnet adapter for that network, okay? So hopefully that you remember that from VMware 4IVM when we learn about VMware. So that's what we're going to do here. So, and just as a further note, obviously the methodology we're doing in this class is that we always practice and learn with the worksheets on the virtual machines we use in class, the practice ones. Once we understand how it's done and they haven't done succeed in getting it all to work, then we try to adapt it based on our understanding and knowledge to what the situation is with our assignment. Okay, don't try to put it straight in your assignment because you'll find things don't match up exactly how you think. You might get things wrong. You might not understand what you're doing. Okay, so learn on the practice virtual machines by doing the worksheets first. And before you put it onto your assignment, make sure you snapshot all your servers at that point. Okay, because what's worse is if you don't have a snapshot and you mess things up totally, you want to go back to a point that you haven't messed up, you won't have it. So I'm telling you, the VPN is probably the biggest hurdle in this assignment that we've found over the years. So take a snapshot beforehand of all the servers. Yeah, if the servers are all off, then the snapshots will be a lot smaller. But if you then go off and do it and you find that you've messed everything up and you just totally lost where you are, just reset it back to that snapshot, all of the servers, and then you can start again. But if you don't have that snapshot, it might mean you have to go back a few steps instead of just one step. Okay, so but let's get into our worksheet today, as assignment, PowerPoint today, sorry. So today we're going to talk about the theory of VPN. And obviously in the worksheets, we're going to implement a VPN in one of, there's going to be the whole heap of choices when we're talking about VPN, but we're going to take one of the options, which is to use it as a IPsec VPN with MS Chat version 2 and with a pre-shared key for security. So obviously there's going to be all sorts of other configurations that's possible, but in our worksheet, that's what we've chosen to use. We can't necessarily go through every possible scenario, we just choose one that's pretty secure because it's using IPsec, and it's actually a good model to follow for our assignment. So today we're going to have an overview of remote access. We're going to look at direct access by using the Getting Started wizard. We're going to implement and manage advanced direct access infrastructure, and we'll implement VPN, and we'll talk about web application proxy. So remote access, okay, so there's a couple of ways of actually giving remote access. Remote access is basically being able to access your LAN from somewhere else, okay, so that could be somewhere on the internet, it could be somewhere at home, it could be if you're on the road going to different clients, organizations. So let me just give you an example. So let me give you an example. Let's say you're working at a company in the CBD, okay, and you live in Elizabeth, okay, and you've just finished for the day, 5 p.m. You finish for the day, you pack your stuff and you get on the train and you go home. But as you get home, you go, oh, I forgot to do that one thing that was asked that now I remember. Okay, I need to do this for tonight's presentation at 9 p.m. I've just spent 45 minutes on the train to get back home. Do I just catch the train back and go to the office and redo that? And the answer is yes, if you value your job and if you have to. Okay. But the problem is that's going to be like a 90-minute two-way process, isn't it? So therefore, wouldn't it be great if we can actually just go home, get onto our computer, use our internet connection, wherever that might be, ADSL, 3G, 4G, even if it's old dial-up or NBN, wherever your internet connection may be. Wouldn't it be great if we can actually just click on a shortcut that's on your desktop that dials up the company's VPN server, gets you, you log in, you authenticate, it checks who you are, and then you're granted access to the network servers. You jump in with your remote access tools, like it could be a remote desktop that we looked at before, and we control the server or the systems that we want to use. It could be just your desktop at work that you're remote desktoping. You perform your task that you're meant to have done, but you forgot. You turn off, and you can relax and enjoy the rest of the night. And that might have been a 5-minute task that you had to do before 9 p.m. tonight. But instead of traveling 90 minutes in and in and back, you could just dial up from home. And that's what this remote access is all about, okay? First of all, to give a worker who's not on the work site to be able to access the resources and do their work. Someone could be working from home, okay? Another part of the remote access is actually how do we connect other networks together. Okay, so you'll find in our worksheet, the first worksheet is allowing remote access dial-in. Okay, so they're dialing in if you're at home as an individual computer or individual user. The second worksheet takes that where we leave off after the first VPN worksheet and then continues on and sets up the site-to-site VPN. What does that mean? That means in our Adelaide site and our Elizabeth site, thinking about the assignment, they are connected with each other through VPN, through IPsec, so it's secure and encrypted, and it is not actually needing you to buy or lease a expensive dedicated connection. Okay, it's actually taking whatever internet connection you may already have and turning that into a private network so you can actually communicate between the Elizabeth site and the Adelaide site. So lots of computers at Elizabeth site, lots of computers at Adelaide site, and they can go through their VPN servers at each end as their gateway and go and traverse the network, going to the other side and accessing the resources, sharing resources, accessing, doing DFS replication, Active Directory replication, DNS, all that kind of stuff that we've been talking about. So that's what we want to achieve, okay? So let's continue. So remote access options for Windows Server 2012 and obviously 16 include direct access, VPN, routing, and web application proxy. So let's actually talk about each one of these a little bit. So you can manage remote access role by using the remote access console or the routing and remote access console. So basically there's a couple of different graphical tools, and what we're going to use is this routing and remote access RAS console. And also, like I've always been saying, anything you can do with a graphic user interface, you can do with PowerShell. And here's an example of a couple of commandlets that you can use to actually get information out of the direct access server, as well as setting information, configuring settings. But like I said, if you want to do some of the Microsoft exams, they do expect you to know these commands, these PowerShell commands, okay? So obviously what we're doing is we're learning mainly the graphical user interface, and we've given you sort of a start in how to use PowerShell last time. But really, if you want to get to the level of actually doing a Microsoft exam, you have to be familiar with the PowerShell commandlets as well, okay? At least not necessarily the nitty-gritty, every little switch, but at least in general, what the commandlets can do and what commandlets do what. And it's definitely pretty hard to actually remember those things if you're not using it all the time. So really, what we teach you in this subject is a level. If you want to do the Microsoft exam, it's a higher level. Okay, so it requires a lot more preparation. So you'll see as part of our configuration, we'll do what's called NAT, Network Address Translation. And you guys all know NAT, okay? You know NAT from your home because that's what your ADSL router is doing, isn't it? It's NATing, or Network Address Translating, from your internal private network to the public network on the internet. We know NAT from VMware because we've got our, what's an internal network, host only network, and it uses the NATing to communicate with the bridge with the actual physical network. So NAT basically is network address translation, and we also should understand, even from VMware, that NAT has advantages. The advantage is that your internal IP addressing system has no reference or no relations to the IP addressing system on the other network. You should know that one of the other advantages is that your internal network is totally hidden by the NAT server, meaning that anyone from the internet or from another network will only see this NAT device or NAT server or NAT ADSL router. They won't even know they're talking to this computer behind the scenes, or this computer or that computer. They'll always think that they're talking to this computer. So basically, this computer is hiding your network structure or configuration behind the scenes, okay? That's a couple of advantages, which is good, because when you're on the internet and stuff like that, you want to hide. You don't want to be visible to anyone that's on the internet, really. Ideally, no one will see you, no one will even know you exist, except for when you're communicating, okay? But one of the downsides of NAT is that it cannot be used to provide a service. So for example, if this is a web server, I'm a client here, I can't just go here and access the web server directly. What you have to do, if you have a NAT device or NAT server or NAT, in order to actually make this service available to the internet, you have to do what's called publishing or port forwarding. Okay, if it's on your ADSL router at home, you probably have configured port forwarding before. Who's done that before? So a couple of you guys, what did you do it for? Games. So that's probably the number one answer. Everyone's nodding their heads for games. So if you want to set up a game server on your network and you want other people to connect to it, then you have to port forward. What port forwarding it means, it's a direct mapping of a particular port that's exposed onto the internet or the other network, and it connects directly to a specific computer on the same port. Okay. In Server 2016, we have what's called Web Application Proxy, which actually is a publishing method. We'll talk about that a little bit later. So NAT server, our server 2016 can become a NAT server. So when we actually create our VPN today, we're going to make a VPN and NAT server. What does that mean? It means that, hey, VPN allows connections in to access our network resources, but NAT allows computers that's in this network to go out to the internet. Okay, so this is going to be our gateway as a NAT server, just like you would use your router at home as your gateway, and it will give you access to the other network or the internet or the physical network in our case. Okay, so considerations for deploying public key infrastructure for remote access. So like I said, we can secure our connections by using certificates. But when we use certificates, we have to have a certificate authority and many other configurations as well. So that's the whole thing is called a public key infrastructure. Okay, that just makes life a lot more complicated for us if we're just practicing one thing. Okay, so for us, we're not going to use a public key infrastructure in our worksheets. We're going to use a pre-shared key, which effectively replaces the need for certificates. But if you are doing this for reals, I would suggest using a public key infrastructure. It just means a couple of extra servers and extra configurations that we need to actually configure. So question is, will you use a PKI for encryption or of data, only data and traffic? Will you use PKI not just for encryption, but also for authentication of users in their computers? If that's the case, then we need to have a way of enrolling those users and computers to get that certificate. We spoke about how we can use a web auto enroll. Okay, and we also talked about how if these are domain joined computers, we can use group policies to enroll these certificates. Number one is, will you be using signed, self-signed certificates or certificates provided by a internal private certificate authority or external public certificate authority? What does that mean? It means anyone can create a certificate, and what a certificate is actually allows you to secure the communication. But how do we know we can trust that person that's providing the certificate? Okay, so if anyone can create a certificate authority, doesn't mean that when you type in your username and password, it's especially if you're going to a site that you don't control, how do you know you can trust that person? So therefore, what happens is that if you do have a self-signed certificate, you'll have a big warning. This is not a signed certificate. What does that mean? It means it's a certificate that person created for themselves. Okay, usually what does that mean? That means I could be anyone. I'll create a certificate. So I could be Mr. Batty. Yes. The Portal IT site has actually an expired certificate, and we've chosen not to renew it because obviously it's an expense that we don't really need because you guys know us. And besides trusting us just because of the web browser saying don't trust us, you know us from a physical attendance at TAFE, as well as me telling you to trust us there. Whereas those certificates are really for websites that you have no allegiance to. You don't control, you go there, and the first thing you're going to see is a warning. And you know what you're going to do, most people are going to do? They're going to say, no, I don't want to take this risk, and back off and not go to that site. In order to not have that problem, you need what's called a signed certificate. Okay, a signed certificate is where you go and pay money to a company like GoDaddy, like VeriSign, like Melbourne IT. There's plenty of them out there, and they issue you with a signed certificate, and based on that, you create certificates to use for your various reasons, websites, VPN, whatever. Okay, that becomes your public key, part of your public key infrastructure. And really, what a signed certificate is doing is not making it any more secure. It's just assuring the person who's receiving this connection to you that this is actually being verified. Okay, what does that mean? It means that, hey, I know Nathan, and I know Dragon, and Dragon knows me, and Nathan knows me, but maybe Nathan and Dragon don't know each other. Probably never met each other before, right? Yeah, you both look a little bit dodgy maybe to each other if you don't know each other, right? So basically, what if I said, hey, Dragon, yeah, Nathan's a good bloke. If you go to his website, you'll know he won't be virus free. He won't be trying to hack you. Then would you feel better about going to his website? Definitely. That's like a vouching system, isn't it? So what a signed certificate actually is basically this third party, VeriSign or GoDaddy or whoever it is, saying, hey, you've paid me money to actually give you a certificate. I'm going to investigate to make sure that you're legit. You're not just some sort of hacking site or virus site that's going to infect your clients. So once I've verified you, I'm happy with your standard in the community. You are a legitimate site that's providing this particular service. I've issued you a certificate. Now that anyone who's gone to your website is basically getting that vouching from me, who's that certificate, what's a signed certificate authority, that his site is okay. It's just like me saying to Dragon, Nathan's okay, you can trust him, and therefore you won't get that error. Okay, so basically, when you do include a public key infrastructure, you should, especially if you're dealing with clients that are not necessarily internal clients. Okay, for whatever reason, websites, for VPN, for anything. If you're dealing with non-internal clients and you don't want the ugly little warning about this is not a trusted site, may not be a trusted site, then you have to pay for this. Okay, like I said, our portal site has an error. Instead of not saying this site's not trusted, it's saying that the certificate that's associated with the site has expired, which means that it was issued ages ago, but right now they haven't renewed their license, so we can't guarantee they're legit anymore. And basically for us, because we're not dealing with external clients, we're dealing with people that we know directly, face to face. We're saying, hey, instead of us paying money to this first site to say we're legit, I'm just going to tell you we're legit. And if you're going to our class and you're meeting me in a class and seeing me in class and you don't trust us, don't go. You know what I mean? So that's why we've done it like that. So we're configuring user settings for remote access. So basically with remote access, we can use user settings on the remote access to include network access permission. So whether you're allowed to access or not. Just because we got VPN doesn't mean everyone just automatically is allowed. We definitely can make everyone allowed, but doesn't mean we should. So basically we can have a couple of things. We can allow access, we can deny access. We can control access through MPS, which is that network policy server that we talked about the other lesson. And how we're going to do it is we're going to use MPS in our worksheets and our assignment. And what does that mean? That means that through the network policies, which is what we talked about, rules, that we're going to say, hey, these users are allowed access and only these users. So we're going to use groups. Okay, we're going to use groups to allow access to certain groups, and if you're a member of that group, you get dial-in access, and if you're not a member of that group, you will not get dial-in access. Okay, easy enough. And also there's verify caller ID, callback options. So these are a bit like the old days when we had dial-up, as in phone line dial-up. So basically, if I had callback options, I could be overseas. Yeah, I could be overseas. I've got a phone and I want to call Australia because that's where my network is. And obviously there's international rates, isn't there? I don't want to pay for those international rates. So those callback options means that I dial up and I disconnect, and then the server that I dialed up dials me back, and we set up a connection that way. And guess who's paying for the bill then? It's not me, it's the company who I'm working for, which is Sincera. So that's really for those kind of situations. Obviously, when we dial in, a computer dials in, they need an IP address, okay, to be able to communicate with your network. Effectively, when you successfully dial into a network, you become part of that network. So you are, instead of sitting on the outside, like we showed you before, instead of sitting on the outside, this computer is on the outside of the network right now, but when it's successfully dialed in, it is effectively on this network here. And therefore it needs an IP address which is consistent with this network that's on the LAN. Okay, so you know what that means by consistent. It has to share the same network ID. Okay, so obviously how we're going to give them an IP address. Okay, we can assign static IP addresses. We can give them IP addresses through a pool, or we can integrate it with our DHCP server. Okay. We can also configure what's called static routes. Okay, so when we actually do our site-to-site VPN, we will be configuring a route from this site to that site and vice versa. So you know what routes are, right? So the routes, and let me just show you my computer's routing table. So on any computer, so especially Windows computers, route print, no slash. All right, so basically this is my routing table of my computer. If you read this, this says any 0.0.0 of a mask, which is 0.0.0, means anywhere. If I want to go anywhere, that's not obviously my local network, I will use this IP address as my gateway. And that is the interface I send it out of. Okay, so that's the routing table of my particular computer. But we all know that on a router, they also have routing tables which instruct it how to get to another network. Okay, you guys know that. Like obviously you guys are doing Cisco, and we know that routers do that, and they exchange routing tables and whatnot. When we actually make our server 2016 into a remote access server, we are effectively turning into a router. Okay, we can even use some of the routing protocols like RIP routing protocol and so forth. But for us, we're going to just use static routes because we've only got only 2 networks. Okay, whereas if we had a more complicated arrangement, we might be using some sort of internal routing protocol. So let's talk about direct access. Okay, so direct access allows us to basically connect external clients, external websites, back and forth into our network by using IPv6 with IPsec. Okay, so we've got various internal clients, internal network resources. We've got our Active Directory with DNS server. We've got a network location server and a PKI deployment. So this is the certificate authority that we're talking about. And we've got external clients and internet websites. And basically this direct access allows us this connection, but with IPv6 and IPsec. So direct access server deployments include deploying multiple endpoints, supporting multiple domains, deploying a server behind a NAT, and supporting OTP and virtual smart cards, and supporting NIC teaming and provisioning off premises. Okay, so NIC teaming, as the name suggests, is where you have multiple network cards teamed together to provide a high bandwidth and load balancing, as well as redundancy. Direct access tunneling protocols include, so basically it's obviously using IPsec, but what if you don't have it's using IPv6 over IPsec, but what if you have IP version 4? What if you're using IP version 4? So we can use ISOTAP, which actually tunnels IPv6 traffic over IP4 networks for internet communication. There's also 64, which is used by direct access clients with public IP addresses. So IPv6 to IPv4, that's what the 64 means there. Then there's Tornado, which is used by direct access clients with a private IP address behind a NAT device. So what does that mean? That means basically you at home behind your ADSL router wanting to connect to the network. We can use Tornado to set up an IPv6 tunnel between our networks and you going through it. We can also use IP HTTPS, which is used by direct access clients if they're not able to use one of these other protocols. Hey, that's interesting. HTTPS, what the hell is that? What's that? What's that normally associated with? So it's secure, yeah, secure what? Hypertext, what's hypertext? Yeah, well, what does that usually transfer? Websites, okay, so the key point is the websites. You're probably going, oh, that sounds a little bit odd here. Why is this protocol, which is normally used to transfer secure websites, doing with this direct access protocol or VPN connection type situation? So obviously, what if, so these are supposing that you're on a network which is allowing this type of traffic. But what if you're not? Well, let's say I'm in a hotel room in the Hilton Hotel and they give me free Wi-Fi access. They obviously have a firewall or proxy server that controls my access, don't they? They don't want me just to go free for all. So if they're blocking all these other protocols, and if I was a network administrator and now I've got a free Wi-Fi access for hotel guests, I'm not going to allow ISOTAP. I'm not going to allow 64. I'm not going to allow Tornado. I'm not going to allow, you know, all sorts of protocols. I don't know. I'm going to be very restrictive. Hotel guests get to access websites and email. That's what I assume that most people want to do, right? So why should I allow anything else? So therefore, you might find yourself in a situation where you're behind someone else's firewall, whether that be at a hotel, internet cafe, or another corporate network. So let's say you're visiting another company. Like I'm a lecturer here at TAFE SA. I might be going to HP to do some training for them, and I'm plugged into their network, and I want to use their network because that's the infrastructure I got to work with. But they've got their own firewalls, and they're not going to allow me to just use whatever protocol I want. They've just opened certain ports because that's what secure network administrators do. So therefore, guess what? If I was a network administrator, would I want to open HTTPS up to allow users to use that? Would you? Would you, Nathan? You're shaking your head. No. Why wouldn't you? You're going against the trend here. Why wouldn't you allow HTTPS? Don't you want your users to have secure web browsing? Yes, you do. Okay, so the answer is yes. Most people would say definitely 100% yes. HTTPS allowed, definitely. But guess what? Because they allowed that, then I can actually use this HTTPS now to connect my direct access, can't I? And that's why it's here. Okay, that's why it's here, because when you're behind someone's corporate firewall, they might be blocking all the other things you want to use, but the HTTPS is a secure way of allowing us to use this, piggyback on this, and get our communication across. Okay. So how does direct access work for internal clients? So again, let's just identify what these things are. We've got internet websites, we've got a direct access server, we've got internal clients with connection rules, an Active Directory, a network location server, a client resource locator distribution point. So when our computer wants to actually access the internet or access resource on the internet, it actually checks with the Active Directory server for connection security rules, then uses the network location server and the CAL distribution point, and then finally communicates with the internet or resources on the internet. How does it work for external clients? So we've got the same computer now, he's at home. So now he's going to check with, the DNS server to resolve the IP address of the external interface of this direct access server. Then it's actually going to form a secure tunnel between this. So it's secure because it's actually encrypted. So why do we need to form this tunnel? It's because that normally when we are home or on the road or somewhere, it's actually the internet we're using, aren't we? We're not using a dedicated lease line to our company. Okay, there's definitely not one that's connected from my house directly to this network here. That's going to cost thousands of dollars every month. And guess what? I'm not going to just stay at home. I'm going to be traveling around the countryside. I'm not going to tow this big piece of cable with me everywhere. So therefore, I'm going to use whatever internet infrastructure I've got. And that usually means public network. What public network means is that anyone can look at my traffic. So if anyone can look at my traffic, if I'm communicating, whoa, these are super duper secure files I want to transfer, then anyone could potentially get those files. So basically by using this tunnel, I am wrapping up my communication in encryption to secure it. All right, it forms this tunnel, and then it actually then can communicate with the internet, internal resources of the intranet. Okay. With the Getting Started wizard, you can configure the following. You can configure a group policy object that actually can have a server settings for the group policy object, and as well as client settings. You can configure remote clients, remote access servers, and infrastructure servers. Some of the limitations of the wizard, Getting Started wizard, is what can't it do? It can't. With the certificates, self-signed certificates, like I said, if you create your own certificates, cannot be used for multi-site deployments. You require to ensure this CAL distribution point for both certificates is available externally, and your network location server design, you need to deploy network location server on the same server as the direct access server. Windows client operating systems that it supports, it's pretty much Windows 7 and above, but even with Windows 7, you require a client certificate for the IPsec authentication. All right, so overview of advanced direct access options. So some of these, again, it's like sometimes it's when you do it, you learn more. And obviously, we're not going to do this direct access in our implementation. We're going to do the VPN. So the direct access is scalable and customize the public key infrastructure. You can customize the configuration options, and it's scalable and highly available server deployments. So when we say scalable, it means it can grow big without redesigning the whole thing. Highly available means that we can have redundant parts, redundant connections, redundant servers, clusters of servers, and so forth. There's customized monitoring and troubleshooting as options for this. So remember logging to a file or logging to a database, etc. When you're integrating a public key infrastructure with direct access, we need to do the following. We need to add and configure a certificate authority server role if it's not already there. We need to create a certificate template. We need to create a CAL distribution point and publish the CAL list and distribute the computer certificates. For implementing client certificates, so computer certificates for IPsec authentication is required for any clients using Windows 7, and we can do this by like we talked about earlier, we can deploy these certificates by actually using group policy objects, or we can configure automatic certificate requests for the computer accounts. We can apply the group policy, and we can verify the certificates are issued. So we'll group policy if they're domain joined computers. Internal network configuration. So when we're planning for internal configuration, we require you to plan direct access server location, where you can place it. Is it going to be on the edge? What does that mean? Edge means it spans internal and external. Okay, internal interface, external interface. I'm on the edge. Or is it going to be a perimeter network? If you've never heard of the term perimeter network, effectively that's Microsoft speak for DMZ, a demilitarized zone, where you have, instead of just one server spanning the inside-outside, you have a inside and outside, but somewhere in between, a demilitarized zone. So you effectively have two firewall servers. And obviously, when we're designing this, the IP addressing, IP assignment is important, and the firewall configuration is important, as well as the Active Directory and client deployments. So, direct access use DNS. Like a lot of things use DNS, but we need DNS for resolving the network location server, any IP HTTPS, the CAL distribution point, and the ISOTAP, connectivity verifiers, and you can configure NRPT by using group policies, and with the following settings: DNS suffix, the distribution point, and a split brain DNS. So if you remember we talked about split brain DNS in the very first lesson, didn't we? That's when you have a DNS for internal and a DNS for external. Okay, so when you have that situation, it's split brain. So that's what it's talking about. So when you're implementing network location servers, it can be located on the direct access server or on another server with IIS installed. And some of the requirements for this network location server is that it has to have a network location website certificate, a client certificate authority that is trusted by the direct access clients, the network location server website certificate, CAL, and the network locations server should be accessible by internal clients. The network location server should not be accessible by internet clients or external clients, and the network location server should be highly available, meaning that it's either redundant, has many redundancies, and whether that be physical redundant components, redundant servers, or logical, which is where you configure clustering or load balancing. Implementing management servers. Management servers in direct access are domain controllers, the system center configuration manager servers. Management servers are detected by direct access automatically or manually if it's modified. Management servers requirements: it must be accessible for the infrastructure tunnel, and it must fully support IPv6. And when we're monitoring direct access connectivity, we can there's components. There's a dashboard component. There's an operation status, and there's the remote access client status and remote access reporting. So it basically gives you a bit of information about the different things. Troubleshooting. So you can troubleshoot direct access by using the a troubleshooting methodology. So your typical troubleshooting methodologies are, including confirming the basics, confirming what should be there. Binary splitting, which basically means narrowing the problem until you identify where it is. There's obviously command tools for troubleshooting and graphical user interface tools as well. All right, so let's get on with what we're going to use in class. Okay, so all those direct access and stuff like that I went through a little bit quickly mainly because we're not using it in class and in our assignment. But what we're going to use is VPN in our assignment and in class. So, like I mentioned, VPN is for connecting remote computers or remote networks to your network. Okay, so if we look at this picture, we can see there's a couple of different ways we can implement it. I could be a user on my laptop anywhere. Okay, I could have my 4G connection and be on the train. I could be in a meeting at another company's site. I could be overseas. I could be in an internet cafe. I could be at home. I could use my home internet connection. I could be a branch office. I could be the headquarters office, medium-sized branch office. Basically, it ranges from an individual person on the road or at home to a network that needs to connect to our network. So VPN provides a point-to-point connection between components of a private network through a public network such as internet. Before we even go on a little further, what does actually VPN stand for? Virtual private network. Okay, so why isn't it an actual private network? Why is it just a virtual? Virtual means not real, right? So it's a virtual private network. It's not an actual private network, is it? What is an example of an actual private network? Yeah, like here, this is an actual private network. These computers all connected by wires we control, or we own, or we're using, connected to each other. Okay, no one else is coming on this network. That's an actual private network. And obviously, if I was a large enough corporation. Let's say we got a corporate head office in Adelaide, and we got another one in Noarlunga, a branch office in Noarlunga. And we're a large enough corporation that we need a lot of communication between these offices and at a very high speed. We might splurge and spend our money and buy what's called a lease line. Okay, we go to ISP and we say we want a fiber connection or a microwave connection between our two sites, or a satellite connection, wherever the connection method that might be, and that's only for our use. And that's what's called a private connection. Okay. But when we're talking about VPN, we're not talking about that. It's saying, hey, we're not going to use a actual private network. We're going to have a virtually private network. It's virtually private because we're not going to spend that lots of money and buy or get a lease line or get a dedicated connection. We're going to actually use the internet connection that we already have. Okay? It's connecting us to the internet. Everyone's got an internet connection these days, don't you? Who doesn't have an internet connection at home? Who doesn't have an internet connection on them right now in their pockets? Okay, that's no one putting their hand up, obviously, because everyone knows that we. Oh, okay, you're luring me, are you? Okay, so basically, we all know that everyone's got an internet connection all the time these days, wherever they might be. Okay, could be ADSL, could be NBN, could be your 3G, 4G. It doesn't matter. At the end of the day, it's an internet connection. And that's relatively cheap compared to a private dedicated lease line. Okay, so, I don't know. I pay $22 and I get 10 gigs of mobile downloads a month. So relatively cheap. Okay. So when we talk about virtual private network, we're saying, hey, we're going to use that internet connection we already got, but the problem is that internet connection we already have is not private. It's public. It's going to the internet, isn't it? Everyone, including the worst enemy, your worst enemy, the person with the most knowledge and skill, and the one that wants to take you down, exists on the internet. We'll always assume that. Okay. So therefore, how do we keep our? It's great we can connect, but there's no point connecting and using it for anything important if anyone could potentially see it or access it or hack you with it. So therefore, how do we turn this public internet into something we can trust and be private? So we actually, instead of actually sending our data just like normally, where anyone can just pick it up, you've sort of done that with Wireshark, haven't you? With Wireshark and your Cisco, you've picked up packets and you're able to actually, if the data is sent in plain text, you could actually piece together the data, couldn't you? Okay. So that's what could happen. So we turn it a public internet that's actually not very private, it's very public in fact, into private by actually using VPN, and we do this by using encryption. We wrap our communication up in encryption. So if you don't know what encryption is, it's basically changing your plain text to a ciphertext, changing your plain data into cipher data. And the way it changes is you use the algorithm to scramble up the data, and you have an algorithm plus a key, and unless you have the algorithm plus the key to descramble it, you won't ever see what the contents are. Okay, we've heard of 64-bit encryption or 128-bit encryption, 256-bit encryption. It's the length of the key. Okay, the longer the key is, the more scrambled it is, and the harder it is to sort of brute force down scrambling. So our server 2016 as well as 2012 here supports these type of VPN tunneling protocol. So what do you need to know? You need to know these ones. Unfortunately, you need to know them and know the differences as far as advantage and disadvantage. So PPTP is really easy to set up, really easy. It provides data confidentiality, but not data integrity or data authentication. L2TP over IPsec is very secure. Okay, it uses either certificates or pre-shared key for authentication, but certificates is the recommended. SSTP uses port 443. Whoa, does that port jump out at you? It doesn't. HTTPS, remember, just like what we talked about before, it uses HTTPS for this protocol. So again, this protocol might not be our first choice, but what if we're in a situation where we're behind someone else's firewall? We're in a hotel room, we're in an internet cafe, and if we still want VPN, we can use this one. But this is only able to be used for remote access, like the individual user dialing in, not for site-to-site VPN. It uses SSL or secure socket layer to provide data confidentiality, data integrity, and data authentication. And there's this IKE version 2, which supports the latest IPsec encryption algorithms to provide data confidentiality, data integrity, and data authentication. Then there's the authentication options. So we sort of mentioned this briefly last lesson when we talked about network policy service. So basically, these are protocols for authenticating. There's PAP. So again, you need to know the advantages and disadvantages. PAP, the worst one. So it sort of goes, this is the worst one of them all because it uses plain text passwords. Typically used if the remote access client and remote access server cannot negotiate a more secure form of validation. So why? Maybe you've got a Windows 3.11 or Windows 95 computer that doesn't know any of these other things. You might still be using this, but that would be ridiculous. So it's the least secure authentication protocol. It does not protect against replay attacks, remote client impersonation, or other remote server impersonation. So what does that all mean? It's plain text, first of all. First of all, if I capture it, I got the username password, okay? Because it's not encrypted at all. It does not protect against replay attacks. What does that mean? That means if I capture the packets for authentication, I could just send it to the server again and use it as if it was me sending it. It doesn't protect against impersonation, meaning, hey, if you were supposed to make a deal with someone that you've never met before, and you were to meet at like, let's say, the conference room at the hotel, Hilton Hotel, like and it's let's say it's a financial transaction, and I know that you're supposed to meet Dragon. I'm using you and Nathan again. I know Dragon's meant to meet Nathan, but what if if I get there early and I go, hey, I'm Nathan. Here's what you want. Yeah, give me the money, and if you just trust me, then that's potentially end in tears because that's me impersonating Nathan, isn't it? So therefore, how do you protect yourself against that? Maybe you want to verify I am who I am. And for me, I need to check who you are. So basically, that's what's called mutual authentication. Okay, that mutual authentication prevents this impersonation. So protect you against the man in the middle attack and that type of impersonation attacks. CHAP is a challenge response authentication protocol that uses an industry standard MD5 hashing scheme. MD5 again scrambles the data, but it doesn't use a. It's a scrambling. It's reversible, unfortunately. It's so it's reversible. So even though it's hard to reverse, it's reversible. It's an improvement on PAP in that the password is not sent over a point-to-point link as plain text, but it requires a plain text version of the password to validate the challenge response. So it does not protect against remote server impersonation as well. It doesn't protect against impersonation. So no mutual authentication. MS-CHAP version 2. So MS-CHAP obviously is Microsoft's version of CHAP, and it's the next level. It's an upgrade on MS-CHAP. It provides a two-way authentication. So basically that's mutual authentication, isn't it? You check who I am, I check who you are. So now we can't impersonate each other. Okay. Provides a two-way authentication. It's known as mutual authentication. The remote access client receives a verification that the remote access server to which it is dialing in has access to the user's password. It provides stronger security than the CHAP. Then there's the EAP, which allows for arbitrary authentication of a remote access connection through the use of authentication schemes known as EAP types. Offers the strongest security by providing the most flexibility in authentication variations. So it goes from least secure to most secure in that sense. Okay. What we're going to use is MS-CHAP in our practice. Okay. What is VPN reconnect? VPN reconnect maintains connectivity across network outages. So for example, if I was connected now, but for some reason the network went down, okay, then it's back up again. What VPN reconnect is, it provides a seamless and consistent VPN connectivity and uses the IKE version 2 technology. It automatically re-establishes the VPN connection if it was already connected, but for some reason your let's say you walked into a tunnel and your service dropped out for a couple of seconds. You walk out of the tunnel. Instead of you having to redial up and re-go through the whole steps manually, it's automatically going to reconnect. Okay. So it maintains the connection if users move between different networks. So that's you heard of the term cells? Yeah, you probably heard the term cell phones, right? So cell phones basically are, just like mobile phones, but basically we're not always connected to the same mobile phone tower. Okay, as we're making a phone call and we're walking from North Terrace to South Terrace, we're going to be in one cell or one area of coverage, and we're going to walk out of that cell and walk into another area of coverage. So we sort of disassociate with one tower and associate with a different tower, and that's basically what this is talking about when users move between different networks. Okay, one cell to another cell, or switching from Wi-Fi to 3G, or vice versa. Okay. Provides transparent status to users. So as far as the user is concerned, it's just connected. Okay. I don't need to know how it's doing the connection. It's just connected. So the user doesn't have to do anything. That's what transparent means. If when something pops up into the user's face and they have to do this or do that, that's not transparent. If it just works and it does its job without the user intervention, then that's transparent. Okay. So again, this will make a lot more sense when we actually do our worksheets. So we can configure VPN by using the Getting Started wizard of the Remote Access Management, or we can actually use the RAS Management Console. VPN configuration requirements include 2 network interfaces. So like I said, inside, outside. If you don't have that, you can't have VPN server. Okay. Address allocations, like I said, when someone dials in, they are actually joining our internal network. So they need to get an IP address that's on the internal network. They can't keep on using the original one. So they will still have that, but they will need another one. So we can provide this IP address by using a static pool, and that's what we'll use in our class, or we can integrate it with our existing DHCP server to allocate these clients with an IP address. We need an authentication provider, so we need an MPS server or a radius server, or the VPN server itself. And in our case, we're going to use a MPS server. So where our VPN server is actually going to send our authentication information to our MPS radius server. We may also need a DHCP relay agent, which is basically if we have DHCP to provide IP addressing, but that DHCP server is elsewhere, not on the same network as this, then we need a relay agent. We'd also need membership in the local administrators group or equivalent. So in order to configure this, we must be administrator. Okay. If I haven't already mentioned this in our previous subjects, whenever you're working on any of these worksheets or the assignment and you're logging on to a computer that's not the domain controller, make sure you log on as the domain admin. Okay, because when you log on to the domain admin, not only will you get administrative access to the local computer, you'll get administrative access to the whole network. So therefore, when you go back and use a resource that's on a network, like the Active Directory, you'll have admin access without requiring further authentication. So that's just a general rule. Always log in as a domain admin. And the first thing I'll ask, if you tell me, oh, I can't do this, I'll ask you, are you logged on as a domain admin? Okay, if you're not sure, you can do a who am I command. So that's just one way of telling. So who am I? Obviously, I know who am I, but who am I as far as the computer is concerned? So this is telling me on the domain TAFE-SA, I am at the moment a user account called Alex Zhao. So if you're logged in as a domain administrator of like our W2K16AD, it would say W2K16AD administrator. If it doesn't say that, if it says something else like AZ what's it, ADLFS / administrator, it means it's a local file server administrator. You just have less problems if you're logged in as a domain administrator just as you're learning. Obviously, in the future, you might have to delegate levels of access for different things, and that's fine as well. But right now, because we're learning, we're just keeping it simple and using the administrator account. Options for modifying the VPN connections. You may need to perform additional steps to help secure the installation of the VPN. So we can configure static packet filters, configure services and ports, adjust logging levels, routing protocols. So by default, okay, when you connect via VPN, if you leave everything by default, just allowing access, they'll have access to everything. Okay, they'll have access to all of your internal network, and that's okay in some situations, but that might not be okay. When we talk about static packet filters, what does that mean? So you guys know what a packet is, don't you? So what's a packet? It's a data unit, isn't it? But which level? Is it a frame? What's the difference between a packet and a frame? Sorry? Yeah, the different OSI levels, yeah. But what's the difference? What does the frame use as addressing? MAC addresses, someone said, yeah. And what does a packet use for addressing? Sorry? IP addresses and so the IP is on the IP layer. What's the TCP layer? Ports. So ports and IP addresses, source destination ports, source destination IP addresses. So when we talk about packet filters, we are actually talking about a firewall that's on this VPN server that's saying this person is allowed to connect, but they can only communicate with this IP address and only on this port number potentially. We could do that. If we don't, we just allow all, that's fine. But if we say, hey, these guys who are getting VPN access, I'm not going to give them full VPN access. I want them to only be able to access this web server, which is our internet server. So if we make Victor here, the web server, he's working on port 80. His IP address is 192.168.20.80. Then we're going to, in our packet filter, we can say destination 192.168.20.80 on port 80. And then the VPN computers who dial in can only access that one resource on port 80. You get me, guys? So VPN normally gives you full access, but we can lock it down. And we can also configure the service and ports like we said just then. We can configure the number of VPN ports. So basically, what if we can't accommodate everyone dialing in? So maybe we can sort of configure that we'll accept 25 connections at any one time. Okay, depends on our connection, internet connection, our server, and our abilities. We can also create a connection manager profile for users. We can add ADCS. We can increase the remote access security. We can increase the VPN security, and we can also implement VPN reconnect. So these are some of the things we can configure. And like I said, it will make more sense when we actually do it. Remember how I always say, when you think of your users and whether they're capable of doing something or not, I personally always think of my mother. Can my mother set up a VPN connection on her computer so it dials up the server that we want and connects? Okay, just even by saying that, I can just hear myself saying no, cringing, no way, she cannot do that. And I'm guessing some of you guys will be thinking the same thing. Okay, so this CMAC allows you to customize a user's connection experience by creating a predefined connection on a remote server and network. So what does that mean? They get an executable file. They put on their desktop. You can say, if you want to connect to the VPN at home, make sure you have an internet connection. Make sure you can browse to Facebook or something like that. And then double click on this. Can my mother do that? Yes, she can do that. She can check Facebook and she can double click on a file that's on her desktop. So basically by doing that, then that connection is established for her. Okay? So this just basically makes life easier for you as administrator to get your users to be able to use this VPN without having to be on the phone with them and saying, oh, have you done this? Have you done this? Did you do this? Or having to go to their computer and manually doing this yourself. So it reduces the help desk requests related to the configuration of the RAS, remote access service connection, by assisting in the problem resolution because the configuration is already done. Reducing the likelihood that users will make errors themselves. You know, sometimes when you're talking to someone on the phone, you can't see what they're doing. You say do this, that they're probably doing something that they think it's that, but it's totally something else. I'm sure you've experienced that yourself. All right, so the next thing we're going to talk about is web application proxy. Okay, this is basically a form of publishing. What does that mean? That means we have an internal resource that we want to actually make available to the internet. So here we have what's called a perimeter network. So we talked about how being a DMZ. So this is a network that we control, but we don't fully trust. This is our internal network. This is the internet. So in this case, our clients are on the internet, but they want to access a resource that's on the internal network, but we don't necessarily want them to dial in and access our internal resources because they're not necessarily our users. They could be just someone on the internet. Like you guys, before you came to TAFE, you looked at the TAFE website. Doesn't make you TAFE SA users at that point. It makes you someone who's looking at our resources. So this was introduced in Server 2012 R2. It functions as a reverse web proxy. So you know that a proxy normally gives internal computers access to the internet by actually acting on their behalf. So we hopefully you understand the word proxy. Proxy is someone who's acting on your behalf. I can be a proxy vote. I can do a proxy vote. If I own shares in BHP and I can't go to a general meeting, I can say, hey, the board can have my vote and they can vote on my behalf. Okay, so proxy is something or someone acting on your behalf, and in this case, in normal sense, a proxy is a forward proxy, meaning internal clients can use this proxy to go to the internet. Okay, in this case, it's a reverse proxy, which means internet clients can use this proxy to access internal resources. Okay, this uses Active Directory Federation proxy functionality. It's located in the perimeter network, or DMZ, and basically our Microsoft application or resource is actually published into the internet by going through this web application proxy. What does that mean? So it means that these computers will actually be on the internet, or these computers or devices. They'll actually go through our external firewall and hit this server and request a resource. This server is actually not the server with the resource. This server is the proxy. So what this server does is then it actually goes through this internal firewall, goes to the resource it wants, gets a copy, stores it here, and then sends a copy to the external clients. You see how with this methodology, none of these external internet people are actually dealing directly with our internal servers. So it's protected, isn't it? So it's protected by 2 layers of firewall, because this one might allow this type of traffic in, but the second one would definitely not allow it into this internal network. This second firewall is more restrictive and probably only allows communication between this web proxy and the resources it's publishing. So what is Active Directory Federation Service? It is a Microsoft Identity Federation solution that uses claims-based authentication. Okay, Active Directory FS includes the following features: Web SSO, single sign-on. Okay, so that's, you sort of would have noticed that with our TFSA, where you use pretty much the same username password for everything. Web service interoperability, support for different types of clients, extensible architecture, enhanced security. Okay, so that's what it provides. So with the web application proxy, we have authentication, and user authentication can be Active Directory Federation Service pre-authentication or pass-through pre-authentication. What does that mean? It means that we can actually just authenticate with Active Directory Federation Service, and then it's authenticated. Or we can actually say, hey, we won't worry about this, we're going to pass through. What does that mean? That means if our server inside has some sort of authentication requirement, then the information which is going through the proxy will be sent to this one, and it will do the authentication. The internal server will do the authentication. Some of the benefits of Active Directory Federation service is that you can have the workplace join. So what does that mean? That means you can take your non-domain computer, like your laptop that you brought in or your device you brought in. They're not part of our domain, but we can actually do a workplace join, which actually gives us access to internal resources as if they were domain joined computers. You can have SSO, single sign-on, multi-factor authentication. Multi-factor is obviously, instead of just using your username password, you can use other things like a swipe card, like a smart card, like your fingerprints or something, or pattern or something like that. Multi-factor access control. So publishing applications with web application proxy, you can configure web application proxy settings by specifying the ADDFS server name, the ADFS administrator credentials, the certificate, and we can publish web applications. So if you don't know what a web application is, it's basically going to any website where it does something, like our Learn, for example. The Learn is a web application. It's more than just providing you a static information. It allows you to do a lot of things, doesn't it? So that's an example of a web application. What's the types of pre-authentication? For example, pass-through. We can configure these things. We can details of application that will be published. We have an external URL. So basically on the regular DNS, we can have a external DNS name that resolves to our web application proxy. A certificate whose subject name covers the external URL, and a URL for the backend server, which is actually its publishing. Okay. So that's the end of the PowerPoint today. It's quite a bit of information. So what I want you to take out of it is more so the VPN than anything else, the authentication methods, the connection methods, and how it works in general. Okay. So